we need to prove sine of x plus y will be sine x cosine y plus cosine x sine y. So we are taking sum of two angles x and y, and we will show how this one is this with the help of geometry and those properties. We have seen that sine of negative x goes in the fourth quadrant, that's why sine is negative. Cosine negative x also in the fourth quadrant. We assume x as positive angle, acute, then cosine is positive in the fourth quadrant. Also complementary angles. If x is one acute angle, then pi by 2 minus x will be its complementary. Then we know sine of pi by 2 minus x is cosine x, and cosine pi by 2 minus x is sine x. Now with the help of all of this, we'll prove this one quickly. So first I take AP is my initial position, and then SC is the terminal, which makes acute angle x. Then further we are moving to say D here, and it is making another angle y. So then from here I have x plus y is my compound angle. Now we take a point here at this on the line AD. Now make perpendiculars. One goes here, another goes on this, it's perpendicular. Then we make another perpendicular here, and from this we make another perpendicular on all this line here. So we label like PN is one perpendicular from P to AC, and then PM is perpendicular from P to AB, and then from N I have another perpendicular NJ on AB. Now we take another perpendicular from N to PM, which is K. Now it is very easy to show that this angle is X. Now we'll be using just SOHCAHTOA, these two, to prove our result. Now what will be my sine x plus y? We isolate the triangle AMP here. So then this angle, this one here is x plus y. Now when I say sine x plus y, so I need to take opposite, which is PM, divided by hypotenuse is AP. So if you look at the line PM can be written as MK plus PK, so you split like that. Next we say MK also can be replaced by NJ. So you can clearly see our MK is same as NJ, same length. So we replace MK by NJ, and then we split also with the denominator NJ over AP, PK over AP. So if you look at NJAN, so with respect to this angle, this is opposite and this is hypotenuse. So this is sine x. Now when I say AN and AP with respect to this angle y, this is my adjacent, so it is cosine y. Plus now say PK. PK is my adjacent and PN is the hypotenuse with respect to this angle, so then it will be cosine x, and remaining is PN AP. So PN is my opposite with respect to angle y, and this is hypotenuse, so it will be sine y. So we have proved our sine x plus y is sine x cosine y plus cosine x sine y. Other results we can go with the help of this. So now we replace y by negative y, so then we get sine x minus y will be equals sine x cosine negative y plus cosine x sine negative y. Now we know cosine negative y will follow this one, it's cosine y, so then we get sine x cosine y. Now sine negative will give me a negative sign, so that's why it will be cosine x sine y. So we got the second formula. Now the third one is little tricky. We'll be using complementary angle, because you know cosine x plus y is same as sine pi by 2 minus x plus y, because complementary angle, you know that cosine will be with respect to sine when you have pi by 2 minus the same angle. Now this one we want to split like this: sine pi by 2 minus x, this is one part, and then negative y is another part. So then this is sine x minus y. We can follow from this. We'll be replacing our x by pi by 2 minus x here, and keep your y as it is. So then it will be sine pi by 2 minus x cosine y minus sine y cosine pi by 2 minus x. Now as we know, sine pi by 2 minus x is cosine x cosine y, minus this one will give me sine x. So then we can write sine x sine y. So we got our third formula. What is the fourth one? If we again replace y by negative y, so you get cosine x minus y, and in the final result we replace y by negative y. So we get cosine x cosine negative y minus sine x sine negative y. So then this one will give me, this one is positive, so you have cosine x cosine y, and then sine of this will give me a negative, and this will come out as a positive. Then sine x sine y.